So I'm gonna call this section normal distribution, okay? And when you think of normal distribution, when you see those two words, okay, you want to be thinking in that thought bubble, you're going to immediately think of a bell curve, okay? That's what you should be visualizing as soon as you see the words normal distribution, all right? And so here are some facts about a normal distribution or normally distributed data, okay? It is the probability distribution, and it is symmetric about the mean. What does that mean? It means that if you were to find the average, if the average is at the center, and then you've got two halves of that curve, right? It's symmetric. They'll be exactly the same on either side. Showing that data near the mean are more frequent in occurrence than the data far from the mean. Okay, so if you think of the bell curve, most of your data is going to be, that's why it's bulging here, because most of the data is closer to your mean. All right. In a graph form, normal distribution will appear as a bell curve. By the way, guys, not everything is normally distributed, but they found out, people that are in math and statistics, they found out that a lot of human attributes are normally distributed. Like our height, right? There's that average height. Most people are around that average, and then you've got on either side, you've got, as you get taller and taller, there's fewer people around, right? There's only one person as tall as me probably in this building. And then shorter, right? The shorter you get, there's also going to be fewer. So as you go away from the mean, there's fewer data points. So they noticed that about IQ, your intelligence, about height, weight, you name it. They can observe this. And in fact, if you ever have little kids, like whenever I go for checkups, like when they're newborn, you got to go in every couple months. And the doctor will always have a chart like this. And it's like, this is the average weight, your kid is here or here, right? So they're very particular about weight. They want to make sure your baby gains weight. So they have a normal distribution there. The mean, right? The mean indicates the location along the x-axis. Okay, you got to understand that part. I'm going to use a different color. And then the standard deviation indicates the scale of the curve along the x-axis. So those two things are very important. Okay? A large standard deviation will stretch the curve. It will flatten it. I think that you already know that. I used to not talk about standard deviation until now, but I introduce it right away nowadays, so you already are familiar with this concept. A small standard deviation will squeeze the curve and make it steeper. Okay, so that's something you already know. Symmetry indicates that, right? Symmetry indicates that half of the values are below the mean, and half of them are above the mean. So you can highlight that whole thing there. Here are some examples of data that follows a normal distribution. Height of people, weight, the migration of birds, like when they come, right? Some of them come like early, but then they trickle in, but then you have, like if this is your time axis, you've got some coming really early, but then there's that one peak, right? Where most of the geese will come in, and then it slows down. Some are super late, right? So if you know what I mean, like there's these geese there by that Shaughnessy there, always annoying, blocking the street, and they stay forever. Like, I'm like, come on, it's already cold, just go back already, right? So they would, that's when they leave. It's the same idea. A lot of them leave about a certain time, but then there will be fewer and fewer that leave super late. Some leave super early, right? But you have this phenomenon called the normal distribution. Baby birds hatching in the spring, right? Time of the year that does are in heat, so that's the deer, right? That they're able to mate. Amount of traffic around a certain time of the day, right? You get your peak rush hour, right? Same idea. The number of COVID admissions at the hospital kind of followed a little bit of a bell curve. So a lot of things that follow it, but not everything. Okay, not everything in life follows a normal distribution. So this is what I need you to fill in, and I would strongly encourage you to have this on your study sheet. This, make it small, but you got to make sure you have that, okay? This is your bell curve. Remember, you still have your frequency y-axis, but normally we omit that when we draw our bell curve. We don't really care about that as much because we talk about percentages. So listen carefully. The whole bell curve will have 100% of the data in it. Okay, 100%. So what they've discovered is that this is your average right here. You can write down mean here. What is that? That's mu, right? That's the letter M in Greek. And that is considered the mean as well. So this letter is the letter mu, which is it's Greek letter M. Okay? Stands for, right? And this is really, if you write it down, that's really the mean. Same as the X bar. You're like, what is it, Mr. Dixon? Is it X bar or what is it now? It could be both. But when we talk about normal distribution, mu is this. So this is the mean. This is where most of your data is going to cluster around. And this letter right here, you already know what this is, right? This is sigma. This is standard deviation. I used to use STD deviation, and then students always chuckled, and I didn't know why for the longest time. It's like, oh, STD, that means something else, right? So I'm just going to write out standard deviation so we're not confusing anything here. Okay, so sigma is a standard deviation. So let's read this graph along the x-axis. What does this mean? Whatever your average is, that will actually be a number, okay, guys? These will all be numbers down the road. But if you were to add a standard deviation, right, you would get that number here. If you add 2 standard deviations, so boom, boom, then that number comes here. And this would be 3 standard deviations to the right. Okay, that's what that means. You can also go from the center, you go minus a standard deviation, you subtract a standard deviation, you subtract 2 standard deviations, and 3 standard deviations. These, every single width here is a standard deviation. Okay, whatever that number is. It could be 5, it could be 10, it could be 9.5, you name it. The bigger the standard deviation, folks, the wider this gap is going to be. And so this curve is going to naturally flatten if the standard deviation is bigger. And I'll show you that later on. Right now, you just have to trust me. Okay? What they know for sure is if you take the mean and you were to include everything from 1 standard deviation to the left and 1 standard deviation to the right, if you were to include this, that is 68% of data points will fall in here under the curve. They will fall in this section right here. Okay? And what they found is that if you go 2 standard deviation to the left and 2 to the right, that would include 95% of, we can call as people, would fall there. And the last one, if you go 3 standard deviations to the left and 3 to the right, that's 99.7% of people would fall in that category. Okay? This is called the empirical rule, 68, 95, 99.7. I'll ask you to write it down later on. So that means because this is symmetrical, that means that this is 34% and this is 34%. Right? The 68 gets split evenly between the 2 columns here. And it follows that if you have 95% and you split that evenly, this would have to be 13.5%. So is this one over here, 13.5%. Make sure you write this down, exactly the same numbers I have. If you have 99.7% and you want to spread it out equally, Because remember, this is the middle, and you've got 50% of your data will be to the left, 50 will be to the right of this curve. But if you're only focusing on between these 2 points here, this would have to be 2.35. I know it's very small, so I'm just going to go arrow 2.35% and go arrow here, also 2.35%. And do you see, I had to work really hard at making this work. Do you see that the curve is never touching the x-axis? Can you see that? It should be obvious to you. It is there for a reason. There is a bit of a chance, there's a tiny chance that you're outside here. So I don't know how to do this other than I'm just going to go arrow. That sliver under that curve is, you ready for this? 0.15% on this side, and it's also on this little sliver here. There's a very slight chance that someone is out there, 0.15%. So if you were to add up all of these percentages, it adds up to 100%. Okay, folks, I need you to understand that. And I hope you have this already in your notes. I know I'm going to give you a lot of information today, and you're going to feel a little overwhelmed, but that's okay. We're going to work with that. So we've got mu is your mean, sigma is your standard deviation. The percentages that you see here is the probability or likelihood of data to fall with 3 L's. How you do that? That's a fail, right? Fall within the range. Okay, that's what the percentages mean. So there's a 35% chance that you're going to be in here, that data is going to fall between this range here. There's a 13.5% chance that you're in here. Okay, so you got to understand that part. And right here on the x-axis here, this could be height, this could be weight, this could be volume, time, etc. Okay, just understand that this could be anything. We could talk about just about anything there. Okay, like did I talk about the Coke can? 355 mLs, right? It says it on every single can. Wrong. That is their average. Some cans have less, some cans have more. And my kids would say, you should check it and sue them. It's like, no, it's too much money. You don't have the money to sue them because they'll just linger. They have all the resources to just stall you in court and you'll never win. All right, anyways, don't do it. But that's also going to be like this. If you grab like 1,000 Coke cans and you're like 355 is in the middle, you're going to have some that are below, some that are above. And the further, let's say there might be a slight chance that you're like at 300 mLs in the can, right? A very slight chance. There might be a slight chance that you have, I don't know, 375 mLs in the can, but not very big chance, right? Another thing I need you to add to this graph, okay, is something called the z-scores. And I'm convinced that it was a German teacher or a German mathematician that came up with that one. He wanted to say the scores, but he kept on saying z-scores, right? And that's how they came up with z-scores. Z-scores, the average would have a z-score of 0. This number right here would have a z, so make a little line like this. This would have a z-score of 1. This value here would have a z-score of 2. This value has a z-score of 3. Okay, then you go back to the mean and you go to this one right here. You make a line like that. That would have a z-score of -1. This value would have a z-score of -2. This value would have a z-score of -3. What does the z-score tell you? Write this down, please. It tells us, I'll write it down right here, z-scores the number of standard deviations away from the mean. I'm going to highlight that because it's very important. What do the z-scores tell us? The number of standard deviations away from the mean. So if a product has a z-score of -2, that means that you're 2 standard deviations to the left of the average, okay? And so forth. You're having fun? I hope so. Make sure you write this down at the very least, and I'll try my best to explain more later. Next, some facts here. The percentage in each section represent the likelihood or probability of data falling within the interval. A normal distribution follows 68, 95, 99.7 rule. Okay, you need to highlight this, and I would say you should have that on your study sheet. A larger standard deviation results in a flatter curve. A smaller standard deviation results in a steeper. Remember, standard deviation also talks about consistency. Okay, that doesn't go away. The total area or probability under the curve is always 1 or 100%. Okay, so you can, if you stick with a decimal, it'll be 1. If you go percentage, it's 100%. So again, if you were to add up even the 0.15 and you add up all of these values, it's always going to be 100% of your data point because you're including everything you've collected. All right. Let's go to 25 here. A little bit more writing notes, and then we'll start working with this, and I'll give you concrete examples. Calculating z-scores by hand. I will make sure you highlight this. Is very important, and these boxes will also be highlighted, meaning hint, hint, add this to your study sheet. To calculate the z-score of a data point, you use this formula. Z is the x value minus the average divided by the standard deviation. Right? X obviously is the mean, and this is the standard deviation. And x is the actual score. Actual value or score. That's how you would find out how many standard deviations away from the mean this particular value is. To calculate the value associated with the z-score, we use this formula and just rewrite it. So to find the value, we would just go z-score times standard deviation plus the average. Okay. And you'll need to know all of these pieces to be able to figure that out. And then grab 2 different colors for this. A negative z-score tells you the value is below the mean. A positive z-score tells you that the value in question is above the mean. There you have it. And one more time though, what does the z-score tell us? The z-score tells us how many standard deviations above or below the mean the value is located. All right. I'm thinking we'll start our example here. Down the road, I'm going to ask you to sketch this, okay? Example number 1. The height of males in Canada is found to be normally distributed. Right away, when you see that, it's not random anymore. We know that there's something true about that. We know this. If you're thinking, okay, this is a bell curve, okay? Also, you're thinking even further. You're thinking of 68, 95, 99.7. That rule should come to mind. Remember this for university, okay? That's the empirical rule. So, we know that the mean height is 177 and the standard deviation is 2.5 centimeters. Okay? So fill out this normal distribution graph here. Right off the bat, we're going to say this represents the height in centimeters. Okay? Fill out these ones here. 68, 95, 99.7. And you might want to memorize this. This chunk right here is 13.5%. Sorry, my bad. That's not 13.5. That's 2.35, correct? Yeah. 2.35. This is 13.5%. This is 34%. And then just copy these values out again going the other way. It's 34. 13.5. This is 2.35. And sure, let's go and put the little wings on here as well. Okay, 0.15, and this is also 0.15%. It's always percent. Okay, so there we go. Next, what we're going to fill in is this. Watch this part. Okay, mu is 177. Okay, that is your average. And now we're going to fill in everything else. So you basically come up with your scale. To go to this, to come up with a value here, you're going to go plus a standard deviation, which is 2.5. Make sure you write that down. So this is 179.5. Keep adding a standard deviation to it. And that is 182. So you, honestly, some of you might just want to grab the calculator and just go 177 plus 2.5. Okay, write that down. Keep adding a standard deviation to it. You get 182. Keep adding another standard deviation because sometimes these numbers get kind of wonky. Okay. So there you have it. You have basically come up with your X scale right now, which is 2.5. Then you go to the other side. You do the same thing. Okay. However, you're going to go minus 2.5. So this is going to be 174.5. Going this way, minus 2.5. That is 172. Keep going. Minus 2.5. That's 169.5. And now you've come up with your X scale. Okay? You've come up with your X scale. The bigger the standard deviation, the wider the bars technically would be. Okay? And so here we go. Now we filled in this, we filled in all of that. Let's now answer some questions based on that. Okay, let's go over here. It's asking, using the graph, okay, later on we're going to use calculators. Using this graph, we're going to answer the following. What percentage of males have a height or are between 172 and 179.5 centimeters? So you go, and 172 is right there, so you put, I need another pencil here. Okay, so 172 is right there, and and 179.5 is right there. Okay, start and end. So what you need to add up is all the percentages that follow or that fall within this range. Okay, so let's go ahead and do that. Show the work, please. 13.5 plus 34 plus 34, right? So I'm adding these three up. So now I will know how many percentage of males are between these two heights. So that would be 81.5% of males are expected, okay, this is a bit of a probability, to be between 172 centimeters and 179.5 centimeters. Okay. Using the curve, that's all I've been doing. I've been using my curve. Okay. C, what percentage of males are expected to be, sorry, there's a typo there, to be taller than 182 centimeters, taller than 182. So you got to go find 182 here. It's right there. Which side would you start adding up? If it's taller than 182, you would add up everything to the right of that. So it's 2.35 plus 0.15. So that ends up being 2.5% of males. Does that make sense? Based on this, right? So 182 is right here. So only 2.5% of males would be taller than this height based on this information that I'm giving you. By the way, this would vary from country to country, from maybe city to city, right? Like the average height. So just so you know, this could be different. I could give you the exact same question with a different average, different standard deviation, and then you would just have to fill this in accordingly. Okay. One more. What percentage of males are shorter than 169.5 or taller than 179.5? What's happening there? I'll do this. You need to add them up. So where's 169.5? Go with me there. It's right here. So you need to figure out, okay, the percentage shorter than that height would be 0.15. So this part right here is 0.15%. Or in math, you'll find this out next year as well, or you want to add. Okay? What percentage of males are taller than 179.5? Go find it here. We already know. We just add up these three here. These three brackets or these three numbers represent males taller than 179.5. So we're going to go put this in brackets like this. This is 13.5 plus 2.35 plus 0.15. And now let's add it all up. 0.15 plus, I'll figure out this bracket. That bracket is 16%. Right, this part. So now we just add 0.15 plus 16. That would be 16.15% of males. Fun stuff, eh? I know. Couldn't wait till this moment, right? I think later on you might have a little bit more fun. Right now you're still, what? Right. Question. Pay attention to this one. Is there another way of coming up with this? And the answer is yes. Let me show you. This whole curve is how many, what percentage is the whole curve? 100, right? And you wanted to know males that are shorter than this or taller than this, correct? So basically, you added up these wings here. What you could have done is 100% minus subtract whatever you get here. Subtract that from 100%, and then you're left with whatever is on the tails. So sometimes you might want to use that one over this method, but both will get you there. Okay, both will get you there. So that is fine. Okay. So far, we've only done percentages. We haven't actually found out how many males are we talking about, because we don't know how many males were included in this survey. Okay? E, what is the range of heights for 99.7% of males? What about 95%? What about 68%? I don't know if you realize this. These numbers should mean something to you. You should be thinking, yes, let's write it down here. Can you see that? Yeah, empirical rule, right? These numbers are not random percentages. They are percentages you should recognize. So let's do one at a time. For 68% of the males, what is the range of heights that would have 68% of the males in it? Let's go back to our graph here. 68 you recognize as this, right? So you follow the lines down, and what do you see? It's between 174.5 and 179.5. That is the range of heights that would have 68% of males in between. Okay, so that's what I'm asking for there, 174.5 to 179.5. So let's do that. To 179.5 centimeters. Okay, that's for 68% of the males. What about 95%? Let's go with 95. 95, you're looking at these two lines, right? So you just follow them down, and that'd be from 172 to 182. Okay, that is the range of heights that would have 95% of males. 172 to 182 centimeters. And then 99.7, I'll let you look at the graph. I won't bring it back up because I feel like it's going to drop on me here. 169.5 centimeters to all the way to the other end. That'd be 184.5 centimeters. So the bigger your gap, the more chances that someone is going to be in between there. Okay, so I hope you understand that. Can I do something else here? This one, you know how else we would refer to this? You would say it's plus or minus 3 standard deviations. 95%, what we're talking about is plus or minus how many standard deviations? 95. Go look at this. This is 95, correct? So it's 2 to the left and 2 to the right. That's what we're talking about there. So plus or minus 2 standard deviations. If it's 68%, we're talking plus or minus 1 standard deviation. So that's another way of referring to these percentages, is just having a standard deviation there. All right, I think I'm gonna do everything up to I. I'm gonna leave J and K for later or tomorrow, okay? And then I'll ask you to try this right away, so you have some time to get your feet wet today, okay, on this. If Canada has a male population of 17 million, so if this is a hard time for you, just put some commas in there. Determine the number of males that are shorter than 172 centimeters. It wants determine the number of males, okay? No longer percentages. We actually want to know the actual number here, okay? So, determine, right, find percentage of males shorter than 172. Let's do that first. What would that be? Can you find that out yourselves? I want you to just take a moment. What percentage of males will be shorter than 172? Go find it using your graph. And leave it up here in your brain, right? Is the answer 2.35? right, that's 2.5. Because this is 172, and if it says shorter, it literally means everything shorter than that. So you need to add up everything to the left of it. So that's 2.5. 2.5%. Okay, once you have the percentage and the total population, you can just multiply them. Okay, number of males shorter, you would go 0.025. Remember, you divide that by 100. I will write that down because every once in a while students get that wrong. Okay, so it's 2.5 over 100 times 17 million. And that gives us, in this case it's a nice round number, 425,000 males are shorter than 172 centimeters. Okay, the wording is very important in this unit. So this is really what this question was after. So this would have given you partial marks, but to get full marks, we want the actual number in this case. Okay, and that was only possible because I gave you the total. If I didn't give you that, all you could do is percentage. This is a probability, a likelihood of that being the case. So we're expecting this many males to be shorter than 172 based on the information. Couple more. What percentage of males have heights with a z-score between -2 and 1? Okay, now we got to go back to our graph for 1 second. Can you highlight z-score? What are z-scores again? To be honest, to quickly fill this in, it doesn't take long at all. Go back to the graph here, and I'm going to use a different color. I'm going to use a different color so you can see that these are the z-scores that I'm adding. What z-score is right where the average is? You get, yeah, it's 0. And the one that goes with this value is 1. The one that goes with this value is 2. The one that goes with the last one is 3. Okay? And when you go to the left, it's -1 here, -2, -3. I'm butchering it a little bit by writing over other stuff. But these, write this down on the side here. These are the z-scores, and we'll calculate these later on. Right now, you just have to trust me, okay? Z-scores. We will find z-scores anywhere in between here, right? You could have a z-score of 0.5, 0.71. It can be all over the place. But right now, we know that these ones in particular that correspond with these numbers are whole numbers, okay? So a z-score between -2, where's -2? Right? That coincides with this line right here. So put your finger there. So we want to go percentage of males that are between -2 and +1. So we want to add up all the percentages that fall in between these two z-scores. Okay? So let's go ahead and do that. $13.5 plus 34. Oops, sorry. Plus 34. And that is, yes, 81.5. Sorry. I'm just checking what else I want to add to this. Maybe I will do this with you here. Put a z-score of 0 in the middle. And then just do one of these. And go 1, 2, 3. -1, -2, -3. Just do that. And just break this down like that. So -2 is right here. So that's the 13.5. This is the 34. And this is the 34 as well. So we're adding the percentages that are found in between. Okay, so between the z-score, so right now we're just interested in the z-scores there. Okay, what is the range of heights? The range, not percentage, it's just the range of heights that would have 95% of males comprised in it. Let's translate that. 95% of males are found within. That's what that is also saying. So it basically wants a height to another height. That's what it's asking for here. I want the range. So 95% would be, in this particular case, I will go back and I realize 95 is, oh, I forgot the percentages. Minus half for units, right? And all you would do in this case is you would write down 172 centimeters to 182 centimeters, because that would be 95% of males in this particular case. Okay? So 172 centimeters, I already have centimeters here, so I'm just going to erase that, to 182 centimeters. That's the range right there. That's what this is asking for. Okay? When it's the range, you don't want actual percentage, you just want to give me from here to here is what we're talking about there. Keep going. I'm going to stop after I for now. Okay? The mean height for females is 162.5. Highlight that part. With a standard deviation of 3 centimeters. Sketch both curves on the same plane. How will they differ? Right? Use different colors to illustrate the differences. So I'm just going to use orange and green if you don't mind, right? So let's just make, I just want you to sketch this. Make a straight line like this. And I'm going to use this one for males. I'm going to use this one for females in my case. You use whatever colors you want. Let's just write this down as well. What's the mean for males? 177. And the standard deviation is 2.5, correct? The mean for females is 162.5. And the standard deviation is 3. First and foremost, if this is the height, males will be somewhere over here at 177. Females will be shorter, right? Their mean is somewhere over here. Correct? The mean indicates where along the x-axis is the highest part of the curve. Okay? You got this part? This is just a sketch. I just want you to think about what would be the difference in the curves. Which curve would be steeper, guys, if you looked at the standard deviation? And if I had $100, I would offer you $100 for the answer, because I think you would answer in no time, right? Or AirPods or something, right? I wish I had that much money. Which one would be steeper between these two curves? Males, right? More consistency. Everything is closer to the mean. So this is steeper. So go to the males right here, and you're going to go up on that average and make a dot way up there. That's going to be the center. That's going to be the top of my hill. And then I'm going to go to the females here, and I'm just going to make sure that hill is lower. Got it? So first of all, I have to figure out where's the mean, where along the x-axis is the top of that hill. Then I have to figure out which hill is going to be steeper. The males are going to be steeper. So don't mix up the colors, Mr. Dirksen. males, okay, orange. So I'm going to go from there, I'm just going to go like this. Boom. You could use dashed and solid, do whatever you need to do. I can almost guarantee you that something like this will be on the exam. Even on the exam, right? I really want you to think, how does this work? Females. You go to females and just make it the same shape, but it's going to be flatter compared to that one. Boom, you're done. You've shown me that you understand how are they different? How would the curves be different if I had them on the same graph? Okay, so the mean tells you how high up the x-axis you are or how low. Okay, that's what the mean does. And the standard deviation tells you how steep will it be compared to the other. All right, I'm gonna stop there for now because I know I've been like giving you a lot of information, but just promise me this: I will give it a try. Okay, and then as you try, I'm gonna go over it, and you're gonna be like, okay, click, click, click. Hopefully, it will click a little bit more later on. So let's go to 27. I'm going to get 27 started because you need a graph to be able to answer these. Normal distribution worksheet using a graph. Have a ruler, please, or something to make a straight line. The volume of pop cans is normally distributed for large samples. The mean volume is 355. The standard deviation is 2.75. This could be for Coke, Pepsi, whatever. It could be that a different manufacturer has, or a different company has also the average of 355, but a different standard deviation. Just keep that in mind. A, this is usually going to be 2 to 3 marks, this part right here. Graph a normal distribution curve showing the probabilities, right, the percentages, that's what that means, for plus or minus 3 standard deviations. Include the z-scores. So you grab your ruler, make a straight line about halfway through this space here. And I need this to be equally spread out. So I'm going to use my ruler to help me out here. So I'm going to go 2. I'm going to start here, and I'm just going to make an equal space. So this is going to be my mean right here, mu. Right? That's going to be my mean, and then I'm going to go 1, 2, 3 standard deviations to the right, left, sorry. And I'm going to go 1, 2, 3 standard deviations to the right. Could have made it bigger if you wanted to. It doesn't matter. And we're talking, in this case, it's volume in milliliters. Volume in milliliters. And the 355 mLs will go right here. You don't have to do units because I already know what the units are. You've labeled it here. And then you just either grab your calculator or do it in your head, whatever you wish. You go 355 plus 2.75. You're going to add a standard deviation. So this is 357.75. You add another standard deviation. 360.5. Another standard deviation. 363.25. And then you go back to the mean. Hold on, Sir Exam, not so fast, right? You go back to the mean. You subtract a standard deviation, so it's 352.25. I probably should have made it a little bigger, but hey, that's, if you're careful, just maybe write it in a slant like this. Okay. $346.75 is as low as we get By the way, you could do 4 standard deviations if you wanted to. 4 and 4 doesn't hurt, but I'm going to stick with the 3. Okay. So that's the first thing I'll be looking for is labeling and these numbers. Then you go to your average, and you go to you just make a point somewhere above it, like right there. I will actually ask you to draw a line like that. Okay, that's the tallest point of your curve because we know it's normally distributed. And then just make a hat, right? But don't touch the x-axis. So you go back here, you do the same thing. And then use a ruler to section it off. Okay? We section it off. So I'm going to go just got to make the nicest bell curve. Right? Just think of Taco Bell and you'll be fine. 34%. So I do the left side first. If the percentages don't fit in there, just go arrow like that. I'm okay with that. Let me zoom in here. Okay, there we go. And then you do the same thing for this side. Just don't forget your percentages. Don't rush too much because then I want it to look nice. Okay, this is 0.15%. And sometimes, sure, the 68, 95, 99.7 is okay to have there, but it's not a requirement. Okay, this would be enough for me. You show me you know how a normally distributed curve should look like. Now I'm going to ask you to answer based on this information. So I will ask you to answer this. E and F you probably won't be able to do, but I gave you those formulas earlier. I boxed them in. If you want to try it, you can do that. But right now, honestly, if you make it to D, I will be fine. A to D for now. Okay? Then try pages 28. Same thing again. And so forth. So I'm going to assign those pages. I think it goes to 29, 30. Yeah, it goes to 29. So I'm going to ask you to try, if you can write this down at the top here, pages 27 to 29. And I will post a key. So if you're not sure, look at the key. It will probably give you some hint or help you out if you need more help, okay?